Hello. Having studied part number one about sustainable packaging materials, eco-friendly materials, and part number two about sustainable food processing, we continue today with part number three about life cycle assessment, sustainable business models. On this first slide, we introduce life cycle assessment or LCA. Is a scientific method used to evaluate the environmental impact of a product and for processing of different industry from raw materials to end of life of the product. This means we don't look only at production, but also to transport, logistic question, and disposal. For food and packaging systems, as you can see in these pictures, this is an extremely important key to successful of any production chain because focusing on a single stage can be misleading. For example, a material may look sustainable during use, but have a high impact during production or disposal. LCA helps industry professional avoid this problem, which we call burden shifting. So it's one of the best question to on access of our course to understand for student, for learners about life cycle assessment. In this slide, we will talk about objective of LCA. The principal objective is to quantify environmental impact and support comparison between alternative solutions. It helps companies, policymakers, and researchers evaluate which materials, technology, or process are more sustainable, depending of their activity, depending of their product, of their process. LCA also support eco-design, regulatory compliance, and sustainable reporting by providing measurable indicators and strengthen transparency and credibility environmental claims, especially in packaging and food industry. The application in food and packaging of the LCA is a very important principal access for any industry because it impacts the production chain from raw materials, as you can see in this picture, from raw materials to and passing with manufacturing, transportation, use of the product, and then end of the product and waste disposal. LCA result to guide sustainable innovation by identifying stage with highest environmental impact. So this helps prioritize the improvement effort and investment of different sectors. About stage of LCA cycle, it depends of each industry, it depends of each processing industry and step of this process. The first stage of LCA define the purpose, the objective of study, and its systems boundaries. Decision made at this stage influence all sequential results, clear definition, ensure relevance and consistency. For example, in this table, we present different elements with different description. For example, for the objective, goal, purpose of the study, and then defined functional unit, basis of comparison between different units, and system boundary. And second second phase and the stage of the LCA. Second, it is the life cycle. Inventory phase involves collecting data and input and output such as raw materials, energy, water, emission, and waste. Displays data intensive and requires accuracy of different steps of processing. LCA provide quantitative and for impact assessment, but reliable data is essential for credible result and meaningful comparison. And first, stage number 3 of the LCA is a LCA assessment. LCA translate the inventory data of stage number 2 into environment impact categories. It evaluates potential impact in different steps, such as impact on climatic changes, water use, human health, and ecosystems. This stage helps communicate environmental, create traceability, to create transparency between industry and consumers, and then give the significant result for each step of your product. In this table, we present different category of common impact categories such as climate change, water use, and energy. And the first step of this, or first stage of the LCA cycle is about interpretation of the result. And this result we discuss in the history of your chain of production chain. We identify hotspots and draw in conclusion. Sensitivity analysis of often used to test assumptions using different materials, statistical analysis, or different materials, some software, for example, or to define the analysis of your the result of your analysis, and then interpret do the interpretation of this result. And this stage support decision making and continuous improvement by linking a result to practical actions directly in process chain. About impact categories of your assessment process, climatic change impact directly measure greenhouse gas emission across life cycle in food and packaging systems. Major contributors include energy use, transpiration, and material production. Reducing emission requires integrated strategies across processing, packaging, and logistics. It's one of the action of the question, the principal question of the impact categories and relative to climate change. Another factor is water use and water footprint, and in this in this impact, it depends directly of the environmental, of the consumption of the water of the industry, of the activity of the industry, with different components such as blue water, green water, or grey water, with different description, for example, as presented in this table. Third one of the impact categories is the waste and resource depletions. This waste, in general, it's depend of the activity of the industry relative to food, fruit, for example, or vegetable, or different compound as used as presented in this picture, for example. And the objective is to improve recyclability and waste valorization, reducing this impact using this concept of life cycle LCA of the process to improve this reduce, recycle, and reuse of the product, as we explained in the last section. About practical LCA and packaging, we begin with this comparison of packaging materials, as we talked on the second part. The materials is very important question point for this type of industry. So LCA is often used to compare packaging options such as plastic, papers, or bioplastic. Results depend on system boundaries and end-of-life scenarios. For example, in this table, as you can see, there is different materials, plastic, paper, and bioplastic, with different impacts in climatic and in climate and environment in general, with recyclability. For example, for plastic is low, medium recyclable compared to plastic and paper. About role and life of scenarios and life management strongly influences LCA result. Recycling, composting, or landfill disposal change environmental outcomes. Designing packaging for effective and life treatment improve sustainability performance. It depends of the nature of the product, the nature of the process, and it depends of the end of the product, his characteristics, sensory characteristic, and uh, and physical characteristic of the product. About definition, sustainable models of business models, a sustainable business model create value with minimizing environmental and social impact with some solution, some technology. It integrates sustainable into strategy, operation, and value creation. Such model balance economic performance with environmental responsibility and gives the solution for this 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 solution as the models to applicate to as a solution for industry. Circular economic business model. Circular economic is, as we explain, is three models in general, three operations as already explained, such as recycling, reuse, or product services. This models it depend of the activity of the industry and product in question. For example, for recycling materials recovery, for reuse it's extended use, and for product services and shared value. About value chain integration, we talk about collaboration across the value chain. That is the objective is to give the value for the product, share its sustainability goals, strengthen long-term resilience, and give efficiency and stability with transparency for different step of your process. About role and digital tools are new technology involved in general in this vision to create the value, the enhance decision making and accountability. With about case studies, many food companies successfully integrate LCA in his process because there is a lot of advantage for this approach. This case demonstrate practical application of theory. Case study provide inspiration and real world relevance for students. We will talk about this in practical section on the last of our course with some case studies to apply the LCA. Packaging companies use LCA optimize material selection and reduce impact. Innovation and transparency are cases success factors. As explained in this table with different cases, for example, for packaging with material reduction and for food with energy efficiency for this type of products. About benefit of LCA, a lot of benefit for different axes. For example, for environmental and economic benefit, LCA-based decision reduce environmental impact and improve efficiency and support compliance. They also enhance credibility with the stockholders and create transparency with the between different professional and also between professional and consumers of the product. Finally, for the summary of this part, life cycle assessment provide a structured framework for evaluating sustainable and food and packaging systems combined with the sustainable business models. LCA support informed, transparent, and strategic decision making, and it is one of the principal points and the principal trends of industry and food products. Now we will talk about part number, move about with part number 4. about food loss, waste, innovation, and value chain efficiency. We will talk about the importance of the valorization of the waste, valorization of the food loss, and what is the solution. In this slide, we begin with the food loss and waste, FLU, FL. We definition and scope. Food loss and waste refers to food that is produced but not consumed, resulting in loss, resource, and value. Food loss typically occur at the production, post-harvest, processing, analysis of your product in different steps of the production, while food was occurring mainly at the trails and consumer levels. Both represent significantly and sustainability challenge for industry and different sectors. So the objective of this part is uh, to learn how manage uh, this food loss and waste of agri-food for food agro industry. Reducing the loss of food loss is essential for improvement food sector, conserving natural resource and reducing environmental impact. As you can see in this figure, in this graph with different food loss and waste in different area for Europe, for example, and for America, for Africa. So you can see that big countries such as North of America. America we have the big consumers, and it's the same for Europe with production retaining important reduction retainment. So this question of food loss waste is a cross with entire value chain and highlight innovation and efficiency as key solution for this type of industry. Importance of addressing of the aspect of food loss and waste contribute to an unnecessary resource use, greenhouse gas emission, and economic losses. Water, energy, and land labor are wasted when food is lost and described. Globally, if we represent a major sustainability concern. Addressing food loss waste support environmental protection, but also support to create the balance between the production and consumption of the product, and it encourage economic efficiency and social equity. Reducing so loss, improve availability and affordability of food while lowering environmental pressure. About source of food loss, the different sources exist. For example, primary production and harvest, and second one, for example, production directly by industry. As you can see in this table, with different source for harvesting, storage, with different cause, for example, poor timing and pests, and for example of crop damage and spoilage, for examples. And there is a lot of source for source of food loss in industry, not just in harvest, but also in pack and processing of different industry with some adjustment in this industry, and there is a lot of food loss and waste drought processing. Processing and manufacturing is one of the important source of as I say in the industry. Food processing loss occur due to timing, storing, equipment inefficiencies, and quality rejections. And while some losses are innovable, many can reduce the drought, better process control. As you can see in these pictures, optimization processing improve yield, improve also the quality and quantity of your product. In this picture, we see this loss and waste by weight for different sectors. For cereals, for example, for roots and tubers, for fruit and vegetables. You see that cereals is the best one for for loss and waste by calories, for example. Then for weight, we have we have the fruit and vegetables from weight per kilogram per grams, for example. That is very important to 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 indicate that this food loss waste impact different sectors, as you can see in these pictures. Distribution and retail is one of the most principal source of the food lost on different industry, caused in general by different parameters such as temperature abuse or overstocking of or some parameters in industry regarding to pressure, regarding to hygiene, for example, also. All this cause the food loss. Environmental impact of food loss. There is an impact, there is a link between environmental impact in general. Food loss contributes significantly to greenhouse gas emission, particularly methane from landfills. It also represents wasted water, energy, and land resource. So it impacts significantly the environment. So reducing of LV is therefore one of the most effective strategies for improvement food system sustainability. We using different solutions as we're talking about it. So economic and social impact of impacts also caused by FLV. Caused by food loss and waste leads to efficiency loss across the value chain and contribute to food and insecurities. Efficient food systems benefit producers, as you can see in these pictures, consumers, and society as a whole for different sections with potential food, as you can see in this picture, for food available and cumulative food lost for dependent of different of the operation such as production, harvesting, processing, storage, transportation, and generalist principal operation caused the food loss, and then storage also is process and harvesting, and finally production. About global and local food loss challenges, difference between region, it depends of the quantity, it depends of the product, it depends of the industry, it depends of technology used and processing. Food loss patterns differ globally. In developing countries, loss occur mainly production and storage stages, while in developed countries, waste occurs mostly at rotated and consumer levels. It depends of the means of any industry. As you can see in this table, food loss patterns by region. For developing region, for example, is production. It's the main food loss factor stage. However, for developed countries, the main food loss is consumption. About data and measurement issues, measurement food loss accurate and is a challenge is due to data gaps and consistency methodology. Reliable data is essential for the policy development and monitoring progress. So analysis, interpretation, standardization of this data, and then give solution is a key point for this area. We will talk about it in practical section for to give some questions, some case study for some question relative to food loss and waste. About technologies that are used for to avoid this question of food loss and waste, innovative processing technology are applied for some industry. In general, for countries, developed countries, such as smart bin systems, for example, route optimization, dynamic scheduling, and demand prediction of the parameters. Innovative processing technologies such as different technologies as applied. The objective is to manage this question. Technology adaptation must consider cost, scale, and key roles requirement for any type of industry. About storage and transport solution, one of the operations that responsible of food loss, there is some solution are applied. For example, cold storage and MAP procedure to manage shelf life of the product and slows spoilage. About packaging is also a solution technological, especially smart packaging technology can provide real-time quality monitoring of your product and avoid food loss and waste. Sensories and IoT applications, as we explained in previous part, it's one of the trends technology that are applied in industry and food industry to improve the quality of processing, the quality of the product. Digital monitoring reduces loss by enabling timely interventions. Monitoring and digital solution also applicate data-driven decision making using some sensors, some analyticals to prediction, to monitoring, to management, this type of analysis. About valorization of food waste, there's a lot of valorization food waste, such as the use of some enzymes and biotechnology, bioenergy, production of fuel, production of some pigments. For example, use of beta-alanine, beta-carotene, as we in our laboratory we develop some technologies using this pigment from vegetable waste to develop some food supplement based on bioactive compound from pigments. We develop also food supplement based on the bioactive agent such as polyphenols of this food waste and with the technical extraction technology, and then we give bioactive product that are consumed as supplements. Integration with the packaging and energy systems, food waste valorization can support packaging production and energy generation. For example, organic waste can be used to produce bioplastic, biogas, for example. About role of government and industry is very essential to govern this question of food loss and waste reduction with the strategies, with the political strategies approach and with the incentives and awareness companies. Industry plays a key role in innovation and implementation, so collaboration between government and industry is a key solution to avoid this question of food loss and waste, as we can see in this pictures with the different levels of reduction of reduction at source, and then food redistribution, animals, and with different sectors, we can improve our the quality of our process with using a strategic and government strategic to applicate it to industry. Also about consumer awareness and behavior, different consumer behavior strongly influences food waste labels, education and awareness. Companies encourage responsible consumption, clear labeling, create transparency, create traceability of the product between to give some information about about the product, and the objective is to reduce food waste and to ensure food safety and minimize plastic packaging as described in these pictures. Uh, Finally, and we will talk about benefit for environmental reduction of food loss waste, saves resource, lowers emission, and improve economic efficiency. It strengthens sustainable across the value chain and improve the industry process, improved quality of the product, improved transparency between the industry and consumers. Finally, as a summary for this part, number 4, food loss and waste reduction is essential for sustainable food systems. Innovation, technology, and collaboration across the value chain enable significant improvements in efficiency and sustainability of industry of the food, agri-food industry in general for different section, but it depends in general of the activity. It depends of the means of each industry to investment in the new technology applied for this question of food loss and waste. That is all for part number 3 and part number 4. We'll move next video for the last parts, part number 5 and part number 6. Thank you.